Hi there. In today's video, I'm going to be starting a new series in which I will attempt to solve a problem in Python. And I will also try to show you, whenever possible, different ways of solving that problem. Also, I will show you how you can start from early on a test-driven approach. Without further ado, let's get started. So the problem I have here today is a very simple problem, just to get us warmed up. We need to create a function that sums all the integers from 0 to n, where n is an integer. So for example, sum all up of 0 is going to return 0, or sum all up of 1 is going to return 1, because 1 plus 0 is 1. Then you have sum all up of 2 is going to return 0 plus 1 plus 2, which is 3. Then sum all up of 3 is going to return 0 plus 1 plus 2 plus 3, and that's going to be 6, and so on. Before we try to resolve this problem, let's just create an empty function. I'm just going to call it sum all up. Okay, it's going to receive a number as a parameter, and for now, let's just return 0. Okay. Okay, you might already know this, but if you don't, by default, Python doesn't need any data types. It will infer the data types at runtime, but that's not always helpful. So now you have an option in Python to actually add some data types to make it easier for you to understand what the code is going to do, and also to have some additional errors in case something is the wrong data type. So in this case, number is going to be an int, an integer. So I could just specify here it's going to be an integer. So this is going to restrict my parameter to int. Another thing I can use for the return type is a hint, and the hint will give you an idea of what it's supposed to return. In this case, I need to return an int. Okay. So I can compile this again, and you can see it compiles fine. For now, it doesn't do anything useful. It only returns 0. But before we add any more logic to this function, let's just create some simple unit tests. So I'm going to create an additional cell. So first of all, I need to import a unit test module. So import unit test. And then I need to declare a class which is going to contain my unit tests. And then inside it, I need to define my test methods. So the first function I wanted to define, or the first test, is a simple base case. Sum all up of 0 returns 0. Okay, so I can pass in as parameter self, it needs that. And then I can do self.assert equals of 0 and sum all up of 0. So for this test to pass, the sum all up function needs to return 0 when we pass in 0. Okay, let's run this. To call the unit test, I'm going to create another cell, and I'm going to pass in these 2 lines of code, and this is taken from the documentation pretty much. And what this will do is just going to run the unit test for us. So let's run it now. And as you can see, it hasn't run any tests, because I think I got this a little bit wrong, because I'm supposed to use the prefix test. So I've created a method, and the prefix is test. Then, because it detects this is a test method, then it will run it. And it has run the test, and it has said it's okay. So the next test is going to also deal with a very simple use case. Okay, I need to make sure everything is indented in the same place, otherwise it's going to throw an error. So sum all up of 1 returns 1. Okay. So you'll notice I'm being very descriptive on my method names. And this is because I want to make sure that this test is very meaningful, so that by looking at the method name, you know exactly what I'm trying to test. So you don't necessarily have to look at the code to know what is the intention. It's all about being explicit. So the assert equal should assert that sum all up of 1 should return 1. Let's execute this and then try again. As you can see, the second unit test is already failing because it says 1 is different from 0. So sum all up is returning 0 instead of 1. But let's just add a couple of more test cases. So SUMLAP of 2 returns 2 plus 1 plus 0, which is 3. So SUMLAP of 3 returns, of 2 returns 3. And then we can keep going as well, just to add more tests. So SUMLAP of 3 returns 3 plus 2 plus 1, 6. And then we can keep going, and maybe I'll stop at 4. So 4, so SUMLAP of 4 is 4 plus 3 plus 2 plus 1. So 10. Okay. Now we have some unit tests. It should be always the same, right? It goes up, right? So I have enough numbers here that I should be able to get a function to work and to be correct. So one thing I wanted to also test is to make sure that a negative number always returns 0. Okay, this is very important. So for example, minus 10 should return 0. So, okay. So let's run this. And now we can see that we have 6 tests, 4 of them failing. Okay, so what we're going to do now, we're going to try and change the code so this test works. The second test, if I want it to pass, then I need to make sure if I pass in a 1 as a parameter, it returns 1, right? So I could say, if I wanted to make this work for the first 2 tests, I could say something like this actually, right? Or it would, if you look at the tests and the results, you'll see that now I only have 3 tests failing. I've managed to get 2 use cases passing. So 2 test cases are passing now. So the first test and the second test, this is called test-driven development because I'm only writing the code up to the point where I have the tests here to work, right? So what I need to do, right? Because now we are calling SUMLAP of 2. I know 2 plus 1 is 3. And then plus 0 is 3 as well. So it should return 3. But if I pass in this, it's going to return me a 2, and that's wrong. So what I need to do, I'm going to take the first number, so 2 plus SUMLAP of number minus 1. This is a very traditional way of coding using recursion. The same function in this case is calling itself, but with a different argument. And the idea is that eventually, when it gets to 0, it's going to stop, right? So the recursion will stop at some point. If I don't have a way to stop it, then it's going to keep going on forever. In fact, if I run this, it should hang because there's nothing here stopping this function, right? So I don't have any if statement to check if the number is 0 or less than 0. So this is going to probably hang, yeah? So I'll just show you what I mean. Well, it didn't let it hang because it detected there is a recursion error. So what Python did was to give me an error message saying that it detected that this method called itself too many times. In this case, it called itself 950 times. And then it said, okay, enough is enough. I know you're not going anywhere, so I'm going to stop now, because this is probably a bug. So the code itself will never finish executing. And sometimes that happens. But in this case, the Python interpreter was smarter and it was able to detect the problem. And it has a limit in the number of recursions. I need to improve this code to make sure it works. So what I'm going to do, I'm going to add the if statement here. If number bigger than 0, I'm going to call the same method. I'm going to do number plus sum all up of number minus 1, because I know that number is bigger than 0. Otherwise, I'm just going to return 0. Okay? And suddenly you'll see that, well, I need to do a return statement to make sure everything is returned. And suddenly you'll see that all these tests should pass. Okay? This is a very simple definition of sum all up. Okay, this is not the most efficient definition, and there is better ways to do this in Python. And I'm going to briefly show you how you can define this function using a different method. So I'm going to add another code cell, and I'm going to create a new version of this function. I'm going to override the definition name, so I don't have to write new tests. What I'm going to do, I'm going to first use the range function. Okay, so what I can do here, I can do a range of a number. Before I even write the method, I want to show you what this returns. Okay, so I'm going to do list of range of 3 so you can see what happens. Okay, so you have a list 0, 1, and 2. But actually, we also want the 3. And the thing is, the range function stops at the number we pass in as parameter. Okay? I didn't define 0 here, but normally you will pass in the start range, and then this is the stop range. Okay? Because we want to include the 3, what we can do, we can just do 3 plus 1. Okay? So in this case, then it will give me the list that I want. And all I have to do now is do 0 plus 1 plus 2 plus 3, and then I get the same result that I wanted to have. So the sum all up. This is the value of sum all up. To get the actual result, the sum, I need to do then a sum of this. Okay, this is using a normal arrays. Okay, but actually I don't even need list, because range returns me already. It's also a kind of a list, but it's a list that's only generated when you request it, basically. So here you'll see. So this is a lazy list, meaning that it only generates elements when you request an element from it. This is much more efficient, because let's say, okay, right now we only have small numbers, but if we had like a sum, like, I don't know, sum all up of 1,000,000, then to actually get the result, if I don't use range, then if I just use a list, then it's going to have to create a list of 1,000,000 elements. And then only at the end, when it has the 1,000,000 elements, it will actually give you a result. And that's not efficient at all. That's going to be very inefficient. It's going to waste a lot of memory. So what Python has is a range function that generates a number every time you need it. So this is going to generate a number every time you are trying to do a sum. So first it's going to give you 0, right? Then you do 0 plus range of, it's basically this definition, actually. It's very similar to this, but this is a much quicker one. So I'm going to define this function here using the range function, and you'll see how much smaller it is. Okay, so definition of sum all up of number int, and then we can just return a range of the number plus 1 and a sum of it. Okay, so now I have the definition of the function, and we can see if this function actually works better or not. So let's run our test again. Let's see what happens. As you can see, it failed one test. So the one it failed, actually there's a bug here. This is not correct. This should be 4. Don't know why it escaped me. So you can see that the test pass. Okay, so this definition gives me exactly the same as this definition, but with only 1 line of code instead of 4. If I run this one, it should also pass all the tests. Let's make sure. Yeah, so all the tests pass with either the functions. So these two functions are equivalent. Okay, there's another way of resolving this problem with Numpy. And Numpy is a library that you get to use a lot if you do a lot of data engineering or data science. And so it's worth to know, right? But it's going to be very similar. So the body of the function will be exactly the same. Okay, and I'm going to import Numpy, and I'm going to use a function called the ARrange function, right? So I'm going to call Numpy.ARrange, and I'm going to pass in a number as well, right? And it works exactly the same as the range function in normal Python. There's a small difference. And the number here doesn't have to be an integer, it can also be a float. Okay, I'm using the very simple definition of a function, but I could pass in more parameters here. I could define a step so that each time a number is incremented, I can define how big the increment is and so on, right? But for now, I'm just using a very simple version. I'm just passing in a number, okay? And it's also a stop number, and that's why I have to add +1, because I also want to include number. So return numpy.arange number +1, and you can see that the test should also work, but they don't. Oh, I missed something. Of course I missed something. I have to do a sum. And another difference is that you do a sum at the end. So the numpy returns you something which looks like an array, but it's not. It's basically, you can call it an array on steroids, because numpy is actually used to handle like huge arrays, like with millions of entries, right? And these arrays are much more efficient than a normal array in Python, okay? So there are also some extra methods attached to the arrays. And for example, this sum method is it's very handy, right? Because if you call this is just going to calculate the sum of between all the elements in that array. So if I run the tests, it should pass. As you can see, all the tests pass. Just to give you an idea what a numpy array returns, I'm just going to add an extra cell here, and you can see it. +1, so 0, 1, 2. Yeah, so it even says array, right? Because it's, but then the difference is you can do sum. So sum is a function that can call directly in array. Okay, so this is it for now. I hope you enjoyed the video. If you like this video, don't forget to click the like button, and I hope to see you again soon. Happy coding!